look at our last seminar in geometry on conditional probabilities and two-way frequency tables. First thing I want you to do is I want you to answer the first 3 questions on this page and then come back and go through the rest of the seminar. And make sure you explain your reasoning when you do questions 1 through 3. What we're going to be looking at today is conditional probability, which we kind of did on the previous lesson. And then we're going to construct and interpret two-way frequency tables. That's what we're going to spend most of our time on, I think. Now, conditional probability, we already said in the previous lesson, but we didn't really calculate. We just assumed what it was. So it's of an event B that is the probability that the event B will happen given that event A has already happened. So what happens, instead of doing your sample space is going to change because you're only going to have to worry about event A. So for example, let's take a look at this picture with this dice. Suppose you have 2 dice that are rolled. It's known that one of the dice is 5. So instead of looking at all of the ways I could roll 2 dice, I look at all the ways I could roll 2 dice where one of them is 5. Notice on this one, instead of 36 choices, there are 11 choices. Now I want to know the probability the sum of the numbers rolled is 7. So if I go through here, 2 and 5 make 7. And 5 and 2 make 7. So really, I've got 2 out of 11. That's the probability that we're going to find of getting a 7 given a sum of 7, given that one of them is 5. Now, to me, I think it's easier just to do it with common sense, but there is a formula based on what we did yesterday. So what it is yesterday we found out the probability of A and B is the probability of A times the probability of B given A. So in other words, to find the probability of B given A, I take the probability of A and B, and I'm going to divide it by the probability of A. So I want to find the probability of both of them divided by the probability that the first occurred. We can take a look at here. That's using these formulas. So I made a Venn diagram here showing if we roll a 5, we have 11 of those choices, don't we? Okay, and then I'm going to look at rolling a 7. And out of those, 2 of them are going to be 5, rolling a sum of 7 with one of them being 5. Notice there's 2 out of 36. So that's where I say the probability of A and B is 2 out of 36. I'll divide that by the probability of A, which is 11 out of 36, so I get 2 out of 11. And 2 divided by 11, that's not one we usually see very often. So we're going to say that probability is like 0.18. And that's what we have. Now if we take a look at this, and I'll show you both ways, and you can decide which way you like better. On example 1, there are 16 customers in line at the deli counter, each holding a number ticket from 179 to 194. Max will help customers holding tickets with an even number. Landon's going to help customers holding tickets with an odd number. If a customer is helped by Max, what's the probability that the customer is holding a ticket 190? In other words, I want to find the probability that we're going to get ticket 190 given that Max is the one who help with the tickets? Well, that's going to be the probability of max and 190 divided by the probability that max helped out. Well, if we take a look here, we got 16 customers, don't we? So I know my sample space is 16. And then what's the probability that we get 190 and max? Well, there's only one of them, right? Only one 190 ticket, and that has to be max as he's doing the even. Now I'm going to divide that by the probability that max is going to help. Well, we know max helps the even ones. So that's 1/2 then, isn't it? So then to find the probability, I'm going to take 1/16. I'm going to divide it by 1/2. And I get 1/8, don't I? That's it. Using the formula. And that works. It works all the time. You can also just use some common sense. That, hey, if max is going to help, I only have a sample space of 8, don't I? Because he only does 8 of them. So that's where the 8 actually comes from. And then out of those 8 tickets, how many of them are even? Or, sorry, even. Let's try again. Those are the even tickets. There are 8 even tickets. How many of them numbered 190? Well, there's one of them. So you just get the same thing if you to me, if you use logic and common sense rather than just using the plain formula. But sometimes the reading is kind of confusing, so you might want to use the formula if you get confused. But I would just use some logic for most of these. Now, the next thing we're going to look at, the second part of our lesson, like I said, the first part of the lesson, pretty straightforward. We're just going to use conditional probabilities and go with them. Now we're going to look at a two-way frequency table, which we've done before. You did that in algebra, and we're going to take a look at it again. So we call it a contingency table also. Okay. And what it does is it's going to show our frequencies from data from a survey or experiment. We're going to classify it according to 2 variables, hence the word two-way table, with rows indicating one variable and columns indicating the other variables. It doesn't matter how you put the rows and columns because this is not independent and dependent. So you might get a different answer than I might have, because you might have them flipped around, but you can still be correct. Now, the frequency reported in the interior are called joint frequencies. So, for example, you got to ask yourself, what does 37 mean? Well, 37 is the number of women who shower in the evening. And then 121 is the number of people who shower in the morning. On your table is actually just this part here. That's easier for, well, we got to include the names too. But the totals, I like to put the totals because that will help us find our conditional probabilities. And then it's also a check to make sure you're doing it right. And so that's what we're going to do with our two-way table. We'll do an example in the next video.